All right, good afternoon, everyone. Welcome to the Almond stage. It's my pleasure to introduce one of our sponsors for the Almond conference this year. It's Qcify. I'm also really proud to say that they're also sponsoring the FFA Silent Auction again this year, which is a big fundraiser for scholarships for students pursuing agriculture. So that's an important part of the Almond conference as well. Based here in California, Qcify has secured its position as a global leader in automated quality control, which we'll hear about today. We're going to be learning a little bit about their newest technology, which is a suite of patented machines with sensors that can deliver real-time data, providing information that will help boost performance. So with that, join me in giving a warm welcome to the CEO of Qcify, Raf Peeters.
So yeah, thank you everybody for showing up here today. As usual, I'm going to try and keep the presentation short. There are some Q&As in the end. And if the questions are too difficult, I'll just start running. So let's get this started. Maybe for those of you who don't know Qcify, I quickly want to go over who we've been. So we started in 2015, and the initial idea was, can we help improve quality control? Can we automate quality control? Can we help take the subjectivity of humans out of quality control? We've been doing that since 2017, so it took us about 2 years to develop the first quality control system, and we started selling those in 2017. Then obviously we started developing additional sensors, which was more the idea, like let's check like a product stream and see if we can see how many pieces of foreign are still in the product. Obviously 2020 happened, that changed the world, and all of a sudden that inline sensor became a final hand sorter. So we started selling the eye machine in 2020. We currently have 31 team members between the offices in California and Belgium, and we have over 400 global installations. And I think it's fair to say up until this year, most people looked at us as an equipment vendor, which we obviously are, but I'm going to explain you how that is going to change. And most people know us of these two machines. So on the left, you see the Qcify sampler. On the right, you see the Qcify sorter. So what is new at Qcify? How did we kind of change as a company? And how are we going to help change the industry and move into the future? I think it first starts with having the right hardware. Because ultimately, if you don't have the right hardware that can capture data, you cannot do any data analytics or line optimization. So we have a couple of new hardware components. We have a new suite of software solutions that require the input and the data of those hardware components. And we couldn't be more happy that the Almond board chose Connecting the Dots as the theme of the this year's conference, because that is exactly what we've been doing this year. So what I want to do first is quickly go over the different hardware components, the new machines that you will also see on our booth there right next door. And I'll just go over them kind of chronologically. Like we said, we started with an automated quality control system. So the whole idea was, let's take a 500-gram sample, put it in a machine, have the data come out of it, and eventually push to ERP systems like the Nutwares, Almond Logics, systems that every plant was using already. While we were kind of transitioning as a company, we also said, like, can we redesign this machine so that it fits in that connecting the dots story better? And that's what we did this year. So we integrated a scale, because now people had to weigh the sample, enter the weight in the machine, dump the sample in. We might as well eliminate that human step. Why? Because all of a sudden, it allows you to tie this machine or put this machine underneath an auto sampler. A system that can take a sample out of the line, drop in the scale, weighs the system. The product can either go in a bin or back into the line. So it just allows for more automation. I'll play a little video. Obviously, you can see the machine there, but the video is here anyway. So for those of you who have our initial QC machine, you probably notice some differences. It is more of an industrial design, it's more robust. We've incorporated all the feedback we got over the years. And that resulted in the Qcify 360. Then the next machine, while we didn't do any major hardware change to it, we've continuously improved the algorithms, improved the performance, the classification. But the reason why I want to show this machine anyway is the last couple of weeks, last couple of months, there have been a lot of reports about Carpophilus beetle showing up in California. I can tell you these machines are already prepared. Why? Because we use machine learning, deep learning algorithms. And over in Australia, they already had those issues several years ago. So that allowed us to already capture data there. And I can tell you, if a Carpophilus beetle hole comes down the line, the machine will see it. So that is the magic, the power of having connected devices, of improving the machines, and not just letting a machine sit idle for 5 years and then come up with an upgrade, but every single season capture data that maybe we've not seen before, or maybe we have not seen it here in California, but the guys in Australia have, or vice versa. That is also who Qcify is as a company. The day we settle for status quo, I think, is the day that I will no longer give this presentation. So we just have to keep pushing ourselves for the betterment of the industry. So here's a little video of the eye. And so transitioning from the eye into the next machine is basically, we didn't kind of go and sit in an office and say like, okay, what can we now develop next? But what we saw is more and more customers were putting in these eye machines as a replacement of final hand sort operations. And all of a sudden in the past, we would sell like 1 or 2 machines to a plant. All of a sudden it became 5 or 10 or 20 machines. And as you can see on the machine, it has its own touchscreen. But if in the morning, if you have to go to each and every individual machine and make adjustments or select what you want to pick out, it's going to take time. And so that made us think like, why won't we come up with like more of a centralized hub or a kiosk that just allows people to control the machines from one single location? And that's how the hub was born. It is, just looking at it, it is a kiosk. It has a huge, not huge, but a big touchscreen. Why? Because the most frustrating part is if you have a tiny screen and you have to figure out which button to press, this just will make life easier for people that operate the systems in the plant. So I'll show you the video. And while the return of investment for this particular system will be in just simplifying the operations, for us, there's a reason why we called it the hub. Because ultimately, this will be your data point. This will be your data gathering system that will further do line optimization. But I'll circle back to that later. And then we have one system left, that's the Ray. I tried to convince the team to call it Raf, but I guess they didn't want to go that route. The reason why we came up with this system is because some customers asked us, well, I have this sort line with, let's say, a Sortex, a Tomra, and a Satake machine in Cascade. Is there a way that you can help us understand how the product quality changes along the way? And we could offer the Qcify or the iMachine, but that would be too expensive of a solution. So we said, like, can we come up with a smaller footprint sensor, a cheaper sensor that will allow to monitor what the rejects in the sorters are? Because very often, and we've been all in plants, you're running and throughout the day, all of a sudden, your 5% good in the reject becomes 20, becomes maybe 50, and all of a sudden, you have to rework a lot of product. Reworking costs money. And so our goal with this system is to say like, okay, we have the hub, we have the other systems. If we can now also have a sensor that ties into that same system, I know we're going to save companies money by not having to rerun or by faster catching deviations in the plant. And that's what Ray is for. The only small disclaimer to this video is you have to ignore the 2 chicken legs that are underneath because they're not part of the system. The idea is that this needs to go into an existing line, but even like a sizer, and I see Mike sitting here, if you have a sizer, you have 8 spouts coming off of it. We envision putting this on each spout as well because then you have real-time on-the-fly data and nobody even has to go and collect a sample anymore. One of the questions you might have now is like, well, in the first slide you said up until 2023 we were an equipment vendor and all we've seen is equipment. And that is true. So yes, we do have 4 pieces of hardware at the moment, but I'm going to explain you through a couple of examples on how we are now going to connect the dots and where the real value of the future will be. So the first one is like what we call a third-party sort line. In our opinion, it doesn't matter what the sorter is, but assume you have some sorters. In this case, it's 2 sorters. It can be 3, it can be 5, it can be 1, whatever the configuration is. And in this case, in order to help you capture the data, we need a couple of pieces of hardware. So here you would need like 1 hub that centralizes the data. And in this case, this customer wanted to inspect the rejects and the accepts of each of the sorters to basically see how the product gets better in quality from input to output, but also to know what's happening with the rejects. So what the rays do is they capture data in those positions. They send the data to the hub, and the hub is then monitoring everything. What is the beauty of this system is we are still not going to be able to change the sorters yet. But that might be a little heads up in the future, but at the moment we're not able to make adjustments yet. But what we can do with this system is we can monitor what's happening. And all of a sudden, if you say like, with my first sorter, I'm aiming for foreign material, and there should not be more than 5% good product in the reject, you can set the 5% as the upper limit. And if you go over 5%, the system will send you a notification. It can be text, it can be email, it can be Slack, it can be any combination of those. And all of a sudden, you no longer rely on an operator by accident walking by the line and realizing that you have too much good in the reject. You can actually see immediate when it starts deviating and goes out of the tolerance that you set to it. So this is one example of how we are tying a couple of pieces together. Another one could be your final hand sort room. And while over the last couple of years we have been installing quite a few of the eye machines, there's now about 250 installed, people still want to capture even more data. And so what we have in this system, we have the final hand sort product. And this is a little video. I don't know if it's going to play correctly, but this is a running almonds, high quality spec. The hub is automatically detecting what machines are in the hand sort room. So basically it looks for machines that are on the same network. And then the layout is like this, and let me briefly pause the video here. So in this particular case, this is a customer, product comes in the hand sort room, it just gets split 50-50 to 2 parallel lines. On each line, they have 2 eye machines, one before and one after the waterfall drop. And then the accepts of those 2 lines go back into the further packaging. So in this case, the eyes are collecting data. The eyes are collecting data that's coming into the machine. So we're already doing that. But then in this particular case, they wanted to say like, well, if we specify what grade we want to sort, is there a way that we can tie those pieces together and not have humans make adjustments and say like, okay, we're out of spec, let's go a little bit more aggressive, or we're within spec, let's go less aggressive. So the 360 in the end inspects the final quality product, pushes the data back into the hub. The hub knows what grade you're packing because you selected and say like, today we're packing a supreme grade. If you're out of spec, then the hub will send signals to the eye machines and say like, okay, we're not meeting, let's say, chipped and scratch. We're at 6%, we're allowed 5%. We're going to figure out which eye is the least used, and we're going to make that machine more aggressive. Why? Because if a machine is already pushed to the limit, you don't want to push it over the limit. But the same is in the opposite way, especially with where prices are at now. If an end customer is paying you to have 5% of defects or something in the product, you better be at 4.75 or at 4.5 or 4 if you want to have a little bit more tolerance. So the opposite is the same. If we have to back off, let's back off the machine that is working the most. So those are a couple of like practical use cases of how we envision tying those pieces together. And that will be different for every single plant because each operations is different. And that's why we designed the system in a way where we can configure this to your needs, where it makes sense and not try and push like one solution that fits all. So that was pretty much in a very short run what we've been up to. As it was already mentioned in the beginning, we're still supporting and matching donations to the silent auction. So you still have until 3 p.m. today to make us pay. So yeah, thank you for listening. And if there's any questions, feel free to shoot.